Alright, we're ready for the Unit 9 test, which means you finished another unit worth of material, so congratulations. So don't be, after we get through this, don't be hesitant to get started on the test, because after you see the examples that I'm going to work out for you now, I don't think you're going to see anything on the test that's going to surprise you. So don't be hesitant. Remember to just to go forth and to charge. Alright, we're going to work some problems out here involving the types of problems that we've seen in Unit 9. We're starting off with an equation. We're going to solve this equation for x. And in this case, to solve for x, I have to isolate the x squared. So I'm going to divide by 4. That gives me x squared is equal to 25. Then I'm going to take the square root of both sides. Now 25 is a perfect square. Remember, plus or minus. The square root of 25 is 5 plus or minus 5 for my two answers. Then it says, what is the square root of 82 to the nearest integer? So I need to know my perfect squares. Remember 1 times 1, 2 times 2, 3 times 3, and so on. There's the first 10. I can see that the square root of 82 is very close to 81. The square root of 81 is 9, so this is very close to 9. Now if you grab your calculator and you punch that in on the calculator, you're going to get 9 with a little bit left over, but again to the nearest integer that would be 9. Now I'm going to simplify this one, but I'm not going to use a calculator on this to try to approximate. I am going to simplify by putting it in simplest radical form. I look at 48 first. Remember, start with a constant. See if there's any perfect square factors. Look back at my list. 4 works, but so does 16, as this is 16 times 3. So I'm going to write this as the square root of 16 times 3x squared. Remember, the square root of 16, that's 4, times the square root of 3x squared. Now, x squared is a perfect square also. The square root of x squared is going to be x. So this is 4, this is x, and the 3 stays underneath the square root. 4x, the square root of 3. Simplifying. To simplify, remember, you can't have a fraction under the square root sign. So I'm going to write this using the quotient property of square roots as the square root of 7 over the square root of 25, which would normally still cause trouble because you can't have a square root in the denominator, but the square root of 25 comes out evenly. The square root of 7 does not simplify. It's already in simplest radical form. And the square root of 25, of course, is 5. So I end up with the square root of 7 over 5. Now, this next question, I'm using the converse of the Pythagorean Theorem. It says, could 5, 12, and 13 be the side lengths of a right triangle? Well, if they are the side lengths, then this would have to be the hypotenuse. So I'm going to call this A, I'm going to call this B, I'm going to call this C. Remember, A squared plus B squared equals C squared. If this is a right triangle, this should hold true. Does 5 squared plus 12 squared equal 13 squared? Well, that's 25, that's 144, and that's 169. If I add those together, yep, it works out. In fact, the 5, 12, 13 is one of the Pythagorean triples that I mentioned in a previous lesson. Problem number 6. You're to determine if these numbers are rational numbers or irrational numbers. Remember, rational numbers are numbers that can be written as a fraction. This is a fraction, so this is rational. Or if it's written as a decimal, it either terminates or it repeats. Whereas an irrational number cannot be written as a fraction, and when you write it as a decimal, is non-terminating and non-repeating. If I punch the square root of 7 into my calculator, which I'll do real quick. Alright, 7. The square root of 7 would be, 2.645751311. It's going to go on and on forever, and it's not going to repeat. This is clearly irrational. Okay. Now my next example, because then I have my calculator close by, I'm to list in order from least to greatest. So I'm going to figure these out real quick. The square root of 22, for example, is 4.7 approximately. This is an irrational number. This, of course, is 5. 15 divided by 3. 3 times the square root of 5 would be 6.7 approximately. And this, of course, is 6.1. So in order from least to greatest, well, I just have to flip these two around. It would be the square root of 22, 15 thirds, 6.1, and 3 square roots of 5 in order from least to greatest. Okay, here's a few more problems. Problem number 7, I can't remember if I finished with 6 on the last one or if I finished with 7, so if I wrote 7 twice, I apologize. You have a right triangle and you're finding the length of the hypotenuse. Well, that's the Pythagorean Theorem. So this is the hypotenuse, this is like your C, here's your A and your B, A squared plus B squared equals C squared, or in this case 8 squared plus 15 squared equals X squared. This is 64, this is 225, does that equal X squared? If I add those I get 289. Well, that one really lucked out, because 17 times 17 is 289. If you use this and the square root button on your calculator, you'll get X is equal to 17 here for the hypotenuse. What's the distance between 2, 7 and negative 110? Well, I have to use the distance formula. That's the quantity x sub 2 minus x sub 1 quantity squared plus the quantity y sub 2 minus y sub 1 quantity squared. And I'll call this x1, y1, and this one here x2, y2, and I'll substitute those 4 numbers in. I get the square root of negative 1 minus 2 quantity squared plus 10 minus 7 quantity squared. Negative 1 minus 2, that's like adding the opposite. That's negative 3 squared, and 10 minus 7, that's 3 squared, so that's negative 3 times negative 3 is positive 9, and of course that's 9, so this is the square root of 9 plus 9, or the square root of 18. Now, they might ask for it to be in simplest form. The square root of 18 has a perfect square factor of 9. This is the same thing as 9 times 2, or the square root of 9 times the square root of 2, and that of course is 3 times the square root of 2. So that would be simplest radical form. If you just punch that in on your calculator, it's going to come out to be 4 point something, and it's going to give you a decimal approximation. It's going to be very difficult to match it on a multiple choice test. Alright, in problem number 9, I'm looking for 2 values, x and y, and notice the special right triangle, 30, 60, 90. So I have the shorter leg opposite the 30 degrees, so the hypotenuse is double that. 4 times 2 is 8, and the longer leg is the shorter leg times the square root of 3. So I get 4 square roots of 3. Now believe it or not, in problem 10 I have a square, and I'm trying to find the length of a diagonal of the square, but that is a special right triangle, because the diagonal bisects these right angles here. That means this is 45 and this is 45, and I have a 45, 45, 90 special right triangle. So I'm trying to find the hypotenuse knowing the legs here. So you take the length of the leg and you multiply it by, do you remember, the square root of 2. And that equals 10 square roots of 2, and this would be in feet. My last example is a trig ratio, and in this case I'm trying to find the sine of angle A, which is right over here. Now remember, the sine of angle A is the length of the hypotenuse, let's try that all over again. It's the length of the side opposite the angle over the length of the hypotenuse. Well, opposite would be 6 and the hypotenuse is 10, so this is 6 over 10, or if I reduce it, 3/5 is my ratio. I could do any of the trig ratios there, but I just asked for the sine. So this should give you a pretty good idea of the things to expect on the Unit 9 test. So remember, before you take the test, watch all through this and get your questions answered, and remember to practice, practice, practice.